Welcome to Precalculus Concept 16E. We're going to use transformations to graph rational functions. I have 3 boxes for you, and let's talk about this first one here. There are 2 basic rational functions that we all must know, and these are the 2 of them right here. On the left-hand side, I have f of x equals 1 over x, and on the right-hand side, I have f of x equals 1 over x squared. I'm really hoping that we already know what these graphs look like, but in case we don't, 1 over x looks like the Hurley graph, and 1 over x squared looks like a tree trunk. So here are the graphs, here are the basic points that we should know for each one of them. For 1 over x, we should have 1, 1, and then we should have 1/2, comma 2, and then 1.5, comma this one right here, or it's 2, comma half. Okay, so these 3 points right here are the ones that we would kind of want to use to make the sketch of this. And remember, this looks like the Hurley graph here. So if I have -1, then -1, and then this point, and then this one right here. Okay, so these are the points that we're basically going to use to make the sketch of this graph. Also, it is to note the center of this graph is at 0, 0. And there is a vertical asymptote at 0, and there is a horizontal asymptote at the line y equals 0. So this one has a horizontal asymptote at the line y equals 0, and it has a vertical asymptote at the line x equals 0. So we found those by looking at the domain and then looking at the degrees. Okay, for 1 over x squared, it looks like a tree trunk. So we should have this one, and this one, and then this one, and this one, and then this one over here. So if I had like -2 squared, it'd be like a 4th. So it's going to look something like this. So it kind of shoots up to infinity like that, and then comes down here and shoots down to infinity over this way. Okay, and it is to note that this graph is also centered at 0, 0. Oh, my toaster's done. Okay, and then there's a vertical asymptote at the line y equals x equals 0 there. And then there is a horizontal asymptote for the line y equals 0 over here. Okay, so we have these 2 basic rational functions that we all kind of must know how to sketch before we can move on. So if you need to make a little bit of practice right now, sketching these in your notes. Okay, box number 2 is all about using transformations to take 1 over x squared and transform it into 1 over x minus 2 quantity squared, and then a plus 1. So we need to take a moment to understand what is this inside minus 2 going to do, and what is this plus 1 going to do. So right now I want you to go ahead and make a guess as to what you think the x minus 2 is going to do to the graph, and then what the plus 1 on the outside is going to do to the graph. Okay, I'm going to walk you through what I want you to get out of this using Desmos. So right now I have f of x is equal to 1 over x squared, and that is the dotted line here, or the dotted graph that you see on the graph over here. This function is dotted lines. Now look what I've done. I have f of x equals 1 over x minus a. A is going to be the amount that we're going to move this graph, but right now a is set to 0. So I'm going to go ahead and turn this one on, and notice it's blue, and you can see that the function now just fits right over all the dots. Now watch what happens when we start putting values in for a. It's moving to the right, and it's moving to the left. So if I stop at, say, here for now, and I try and put this right on -3. If a is -3, x minus -3 means x plus 3, and you can see that the graph has been moved 3 units to the left. So x plus 3 is 3 to the left. If I go to the other direction, and you can see that if I had x minus a positive 3, x minus 3 would be 3 to the right. 3 to the right. So what do you think the x minus a does to the graph? Okay, so I have turned on the x 1 over x minus 3 all squared. That's in purple. And we can see that if it's x minus 3, then it has been shifted 3 to the right. Now I have a plus b on the outside over here that I have not yet turned on. And I'm going to set b to 0 for right now. And then I'm going to turn this on. So when I turn this on, you can see that the orange graph is now lit up. But when I let b go, you can see that now the graph moves up and it moves down. So if I go down 4 units, look, my whole graph has been moved down 4 units. The center has been moved down 4 units. So what do you think the B on the end of the graph does? Okay, now let's go back to box 2 and let's figure out what we can do here. So first I'm going to start by graphing 1 over x squared. So I'm going to have this point, and then I'm going to have the tree trunk that looks kind of like this and looks kind of like that. So that's your first move by graphing the basic transformation function of 1 over x squared. And the center is at 0, 0. Now, if I'm going to move this thing, it says x minus 2. That means I'm going to go 2 units to the right. So I'm going to bounce 2 units to the right. So there's my center point. And then I'm going to go up 1 unit. So there is my new center. So what I'm going to do is draw everything around that being my new center. I'll still have my vertical asymptote, and I'll still have my horizontal asymptote. So now if I consider that point like my new origin of 0, 0, I can then quickly make the sketch of what the graph should look like from here based off of the orange graph here. Okay? So the 1 over x squared has been transformed to the orange graph by moving 2 units to the right and 1 unit up. Okay, box 3 is a you try. Do your best right now to make a sketch of this is the function 1 over x plus 2 and then a plus 3 based off of the basic function 1 over x. So notice this is not going to be the tree trunk, this is going to be the Hurley graph, so do your best. Okay, hopefully you realize that 1 over x plus 2 is going to move 2 units to the left and then 3 units up, so your new sketch would look like this. And you can easily identify these 2 points, -1, 4 and -3, 2. So that's what your sketch should look like in your notes.